I want to introduce an idea here that we can use with complex numbers, and it's a very useful concept called a conjugate. And what a conjugate is just sort of flipping some numbers around, which usually doesn't matter, but for complex numbers, it's very useful. So I'll give you an example of what a conjugate is. Let's say I have x plus 1. Okay? It's not complex, it's just a regular old x plus 1. The conjugate of this, conjugate of this would be x minus 1. Okay, all you do when you're looking for a conjugate of something is you keep the first term and you flip the sign on the second term. So if I said 3 minus 5, then the conjugate of that would be 3 plus 5. And for the most part, things like this aren't very useful. We'll get into some applications with regular polynomials where the conjugate is useful, but right now I want to talk about complex conjugates. So let's just take an example. I'm going to say z equals, let's just make this up, 5 plus 7i. Okay, that's my complex number. It has a real part of 5, a complex part of, imaginary part of 7. Now the complex conjugate, I'm going to write as the z with a little hat over it, and people use all sorts of symbols to mean conjugate, but that's what I'm going to use here. The complex conjugate of z, as you might guess, is 5 minus 7i. And why this is useful is this. If you multiply a number by its complex conjugate, something interesting happens. And let's just watch this play out, okay? I have z, which is 5 plus 7i, and I have the complex conjugate of z, which is 5 minus 7i. And watch what happens as we multiply these two things together. I'm going to go first, outer, inner, last, right? We're just going to FOIL this thing down. So the first part is 5 times 5, that's 25. The outer is 5 times negative 7i, so that's negative 35i. The inner is this, that's positive 35i, and you can maybe see what's going to happen here. And the last is 7i times negative 7i, which is negative 49i squared. Okay, let's simplify this by combining like terms. The negative 35i and the positive 35i cancel out. So all we have is 25 minus 49i squared. And if you remember what I squared is negative 1. So this becomes 25 minus 49 times negative 1, which is, of course, 25 plus 49, which equals, drum roll, 74. So what happened here was we multiplied a complex number by its complex conjugate, and the imaginary terms disappeared. All we're left with is a real term. And why this is useful is this. When you express express a complex fraction, and I don't know how much we're going to get into this in the lessons, but let's say you have something like 1 plus 1 divided by 1 minus I. It is not useful, for a number of reasons, to have complex numbers in a denominator. That is inconvenient for us. So it would be nice to express this thing here as something that does not have a complex number in the bottom. Maybe it has a complex number in the top. That would be okay. So what you can do is multiply by 1 plus I over 1 plus I. We've talked about this idea of the crazy 1 before. This thing is a crazy 1. What's 1 plus I divided by 1 plus I? Well, that's just equal to 1. But when you multiply the fraction on the left by 1 plus I over 1 plus I, what you get on the top is 1 plus I, because it's just 1 plus I times 1. And what you get on the bottom, you're going to have to go through the math on this, but you would get 1 plus 1. Okay, pause the video if you want, run through the math of the complex conjugate of 1 minus I times 1 plus I. You'll get 1 plus 1, and this would be just 1 plus I over 2. And for a number of reasons that we won't get into, this is a preferable form than this guy right here. Okay? Now, this idea of a conjugate goes further than just complex numbers. We'll be using this later in the year when we get into various types of fractions with variables, and sometimes fractions that have fractions inside them. Complex conjugates will be useful. there and in trigonometry as well. So keep this idea right here of a conjugate in mind.